Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2021, paper 3, Foundation 2. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. In a survey, some students chose their favourite type of film from a list of 5. The bar chart shows the results. You can see a bar chart. We've got bars for action, comedy, horror, rom-com and thriller for both year 10 and year 11 students. It's a composite bar chart, so we've got like both year 10s and 11s on the same bar. Okay, haven't we? So let's have a look at the questions. How many students chose action films? That's just the height of the action bar then, isn't it? And we can see the action bar is of height 10. So that's going to be 10. Part 2 says how many year 11 students chose action films? So year 11 students are the kind of stripy ones. You can see the bar starts at 3 and goes up to 10. So how far is it from here down to here? Well, 10 subtract 3 is 7, isn't it? So it's going to be 10 subtract 3 equals 7 students. So that's my answer there. What type of film was chosen by the most year 10 students? So which is the highest bar for year 10? I think it's this rom-com one, isn't it? So that's rom-com. And then finally, how many year 10 students took part in the survey? Well, you've got 3 in this bar, 2 here, 5 here, 7 here, and 3 here. So we're going to add those together then, aren't we? So 3 plus 2 plus 5 plus 7 plus 3, what's that equal to? 5, 10, 17, 20, 20 students. Okay. Part D says 45 students took part in the survey. Write the ratio, number of year 10 students taking part to number of year 11 students taking part in its simplest form. Okay, well, in part C, we counted the number of year 10 students, and that came to 20. And if there are 45 altogether, then 45 minus 20, that leaves me 25 students. They must be the year 11s, isn't it? So we got the ratio of 20 to 25. And then we need to cancel that down. Ratios counts down the same way as fractions. So yeah, if you had 20 25ths, you'd notice that the 20 and 25 have got like a common factor of 5. So dividing both sides through by 5. So divide 5, divide 5. We're going to get 20 divided by 5 is 4. And 25 divided by 5, that's 5. So that's my ratio in its simplest form, 4 to 5. Question 2, use your calculator to work out. And part A says root 196 plus 29. So just going to type that in. There's the root key. 196. Now I need to press the right key to come out of that root, and then before I press the plus, otherwise it's going to continue under the root, which I don't want, and then I'm going to add 29 on the end. Okay, So make sure it looks like it's got on the page and that root sign doesn't go all the way over across to the 29, otherwise you're going to get the wrong answer. If you do it correctly, it comes out to be 43. Okay. Now, then I need to do 4 to the power of 5. So I'm going to press the 4 key first, and then I'm going to press this power key here, which is like an X with a little box. And in the box, I'm going to type in the power of 5, and that gives me 1,024. 1024. Question 3. There are 150 coins in a jar. 20% of the coins are 10p coins. 3/10 of the coins are 20p coins. The rest of the coins are 50p coins. Work out the total value in pounds of the 150 coins. You must show your working. Okay, so we need to work out the number of each type of coin first, don't we? I'm going to start with the percentage thing here. 20% of the coins are 10p coins. Okay, so I need to do a percentage, find a percentage of a number. So using the triangle FOM, final original multiplier, I'm going to work out what my percentage is. Okay, so the final is the thing I want to find. That is the percentage, that's the number of coins that represent 20%. Then original is the number of coins I'm starting with, that's 150. Now the multiplier then is going to be 20% written as a decimal. So what's 20% as a decimal? That's 0.2, isn't it? So then covering up the thing I want to find the final. That tells me that the final is equal to the original times the multiplier. Okay, the original is 150, the multiplier is 0.2. So what's 150 times 0.2? I think that is 30. Okay, so there are 30 10p coins. So let's just make 10p coins. Let's make this a little head in here. So that's 10p coins. Right, let's move on and look at 20p coins. How many of those have we got? 3/10 of the coins are 20p coins. So then the number is going to be 3/10 of 150. You can just do that on my calculator, or you can do it in your head if you're quick. You can either use the fraction key to type in 3/10 times 150, but I know that 150 divided by 10 is 15, times by 3 is 45. So for me, it's just as quick to do it in my head. And then finally, it says the rest of the coins are 50p coins. So the number of 50p coins, that's going to be the total number of coins minus the number of 10p coins, which was 30, plus the number of 20p coins. Okay, so what's that then? That's equal to 150 minus 75. And then 150 minus 75, well, that's 75p, 75 coins then, isn't it? Okay, so then what's the total value in money? Total value. That's going to be all my coins added up then, isn't it? So I've got 30 10p coins. So I'm going to have 30 lots of 10p. I'm going to write it as 0.10. I'm going to write it as a decimal, so I'll get pounds and pence at the end. It does want me to write the answer in pounds. So if I do it in as a decimal to start with, I won't have to convert it later. So I've got 30 10p coins. I've got 45 20p coins. I'm just going to write that as 0.2. And then the rest of them, 75 coins at 50p, which is 0.5, isn't it? 0.50. So what's all that then? I'm just going to type all that into the calculator. 30 times 0.1 plus 45 times 0.2 plus 75 times 0.5. Now that comes to 49.5, or £49.50 then, isn't it? 49.5, which in pounds and pence is £49.50. It's good practice to make sure you don't miss that last zero off, because if it's in pounds and pence, then this should really be shown to 2 decimal places like that. Okay, well, 6 marks, that's nice. It wasn't too hard for that. All right, let's move on. Question 4. A sports team played the same number of matches in 2019 and 2020. The 2 pie charts summarize their results. So you can see in 2019, a quarter were won, a quarter were drawn, and half were lost. And in 2020, half were won, a quarter were drawn, and a quarter were lost. So what fraction of the matches did the team win in 2019? So the win is this section here, isn't it? Okay, which is 1/4. So that is 1/4. Did the team's results improve in 2020? Explain how you know. Well, they did, didn't they? Because in 2019, a quarter of the matches were winning, and then in 2020, half the matches have won. So they won twice as many, basically, didn't they? We know they won twice as many because it does say here that they played the same number of matches in 2019 and 2020. Okay, if we didn't know that, then we couldn't be sure that they'd won more matches in 2020 because they might have played less games. Okay, so we're going to say, did the team's results improve in 2020? Explain how you know. Yes, because the fraction of games won increased from 1/4 to 1/2 of all matches. Question 5, increase 600 by 17%. Okay, this is another percentage question. Again, I'm going to use my triangle FOM, stick your thumb on it, to help work these out. Now, I use this triangle for every percentage question because it works for all different types. And I think it's just a handy way of remembering all the different variants of the various percentage questions. So the final is the thing I want to find, isn't it? That's what I'm going to get after the increase. So again, that's what I want to find here. Now the original, that is the 600 that we had to start with. And the multiplier, just take care of the multiplier here because we need to increase by 17%. So we always start with 100% when we do percentage increase decrease questions. So if we're increasing by 17%, now we've got 117%, which is a decimal, is 1.17. Okay, so then that is going to be my multiplier, 1.17. Okay, so then cover up the thing I want to find. I want to find the final. Tells me what to do with the other two. Final equals original times multiplier, which is 600 times 1.17. Okay, just tap that into the calculator then. 600 times 1.17, that comes to 702. Okay, 702. Question 6. The diagram shows how a rhombus is made up of joining two equilateral triangles. Find the size of each interior angle of the rhombus. Okay. So in bold over here, look, it says equilateral triangle. So if I divide this shape into two triangles by drawing a diagonal line from that corner to that corner. Okay, I'm just going to do it dotted because I don't actually want the triangles. Now you can see then that in an equilateral triangle, all the angles are going to be 60, aren't they? They're 60, 60, 60. So that is 60. And that is 60, and that is 60. And then, of course, in the second triangle, that is 60, that is 60, and that is 60. So in terms of what the angles of the rhombuses are, you've got the two 60-degree angles at either point, so 60 and 60. But then these ones here, look, are made up of two 60, 60 and 60, so that adds up to 120. So that one and that one are going to be 120 each, aren't they? Okay, so 120, 120. Okay, quadrilaterals should add up to 360, and they do, so I'm happy with that. The same rhombus can be made by joining two copies of an isosceles triangle. Find the size of each angle of the isosceles triangle. Okay, so I'm just going to kind of draw another parallelogram next to this one. So yeah, so a rhombus is not a parallelogram. So in the last one, we kind of divided that corner to that corner, and we were told that they were equilateral triangles. But we could have divided it that way instead, couldn't we? because we know it's the same shape as the previous one, then all the angles are going to be the same, aren't they? Okay, so if I divide it up in this direction, then I already know that this angle up here, look, that's going to be the same as the other one. That's going to be 120. And then this angle down here, that's going to be half of this one. These two are going to, this kind of diagonal bisects this angle, doesn't it? So if altogether it was 60 down here, and I divide it by 2, look, I'm going to get 30 and 30. Okay, so that's going to be 30, that's going to be 30, and that's going to be 120, adding up to 180 altogether. So find the size of each angle of the isosceles triangle. That's going to be 30, 120, and 30, adding up to 180. Okay. Question 7. Rowan's bath has a hot tap and a cold tap. When turned on full, each tap on its own will fill the bath in 6 minutes. Okay. So Rowan turns both taps on in full. How long will it take to fill the bath? Well, if it takes 6 minutes to fill the bath with one tap, then each tap is put in 1/6 of the volume of the bath per minute, then, isn't it? Okay, so I don't know what the volume of the bath is, but I know that 1/6 of it is filled every minute from each tap. Now, if you've got both taps running, then that's going to be, for both taps, that's going to be 2/6, isn't it, or 1/3. So it's going to fill up a 2/6 of the bath per minute. So that's for one tap. 2 taps is going to be 2/6 of the bath per minute. In other words, 1/3 of the bath is going to be filled up every minute. And then that means that the whole bath is going to be filled up after 3 minutes, then, isn't it? 1/3 times 3 is equal to 1. So that must mean that it took 3 minutes then to fill the bath. Okay. Question 8, simplify 5t minus 3u minus t plus 5u. Okay, so we're going to collect like terms here. We've got terms in t and we've got terms in u. Okay, so collecting the t's together, I've got 5t minus t. Now notice when I highlighted these, I highlighted the sign that went in front of them too, because they belong to the sign that follows. So that should read 5t minus t. So that's 4t for the yellow ones, for the t's. And then for the green ones, I've got 5u and minus 3u. Now I could do minus 3u plus 5u, but because it doesn't matter which order you do addition, really, I can do 5u take away 3u, which is going to give me 2u. Okay. Either way, it gives you 2u, but that's kind of simpler that way. So 2u is my green bits. So that's my answer, isn't it? 4t plus 2u. 4t plus 2u. Question 9. The universal set contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's all the numbers from 1 to 16. Set A is the odd numbers. Set B is multiples of 5. The elements 1 and 2 have been entered in the Venn diagram already. Yep, there they are, 1 and 2. Complete the Venn diagram to show all of the elements. Okay, so some of these numbers are going to be multiples of 5, and some of them are going to be odd, and some of them are going to be both. I think it's probably easiest if I find the multiples of 5 that are odd first. So the multiples of 5 that are odd, 5 is a multiple of 5 that is odd, 10 is a multiple of 5 but it's even, 15 is a multiple of 5 which is odd. So those two numbers, they meet both conditions, don't they? They're odd and they're multiples of 5. So I'm gonna start with those. I'm gonna put them in the middle. So that is the number 5 in there, and the number 15 goes in the middle too. Okay. So now I've done that, let's pull out the other multiples of 5. So the other multiples of 5 is going to be 10, isn't it? 5, 10, 15. Okay. So then there's only one of those that isn't odd, so that one then belongs in here. Okay, then I guess then we've got the odd numbers that are not multiples of 5, like that one, that one, that one, that one, that one, that one, and that's it. They belong in set A but outside B, so they're going to be over here by the 1. So we've already got the 1 value here. Let's add the 3 the 7, the 9, the 11, and the 13. Okay, and then the remaining ones, then they're going to be sitting outside the set. Now we've already got the 2 showing outside the set, haven't we? Okay, but then we need to add the 4, the 6, the 8, and the 12, and the 14, and the 16. They're all going to be floating around outside the circles. So we're going to add the 4, the 6, the 8, not the 10, the 12, the 14, and the 16. They belong outside the circles, but inside the universal set. Okay, so that's my completed Venn diagram. Part B says the universal set is all positive integers. Set L is the set of odd numbers, and set M is multiples of 2. 3 Venn diagrams numbered 1 to 3 are shown below. Which diagram best shows the relationship between set L and set M? Give a reason for your choice. Okay, well, Venn diagram 1 shows 2 sets where there is an overlap, which means that some in L do belong in M, but there are values in L that don't belong in M, and there's values of M that don't belong in L. Okay, set 2, L and M are distinct, they don't intersect. That means that none of the values in L are in M, and none of the values of M are in L. And then in the third one, we've got the set M totally inside the set L, which means all of the values of M are already in set L. So M is a subset of L. Now what we've got going on here, so here, all the odd numbers, they're like the numbers 1, 3, 5, 7, 9, and so on, 11. And all the multiples of 2, they're like 2, 4, 6, 8, 10. So just looking at these numbers, all of the ones in set M are different from all of the ones in set L. Now obviously I haven't found all of them, but I can imagine they're going on in the same pattern, aren't they? So all the odd ones are 1, 3, 5, 7, 9, 11. All the multiples of 2, they're all even, so they're not going to be in set L, are they? So it's going to be like this second one here then, isn't it? It's going to be this setup where your 2 sets don't ever cross. Okay, they're all separate from each other. Okay, because the numbers 1, 3, 5, 7, and so on are different from the numbers 2, 4, 6, and 8, and all that. Okay, so I'm going to say that it's Venn diagram 2. Venn 2, because basically all elements in set M are even and so cannot be in set L. Therefore, there is no intersection between L and M. Question 10. A student has some cubes that are all the same size. Each cube is 3 centimeters by 3 centimeters by 3 centimeters. They put 4 of the cubes together to make this shape. Calculate the surface area of the shape. Okay. Well, the surface area of a cube generally is made up of the areas of each of the 6 faces. Okay, so if you imagine one of the face of this cube, like this face here, that is going to be 3 in this direction and 3 in this direction. So each of the faces is going to have an area of 3 times 3 then, isn't it? Area of each face is going to be 3 times 3, which is 9 centimeters squared, isn't it? Okay. Now normally, if I wanted to work out the surface area of a cube, I would then multiply that by 6, because there are 6 faces of a cube, aren't there? Okay. Now the problem with this question is that I've pushed 2 cubes together, or more than 2 cubes together. And where you push the 2 cubes together, then one of the faces of one cube kind of sits on top of the face of the other cube, and therefore it is not part of the surface area anymore of the shape. it's then internalized within the shape, isn't it? So if I was to draw this kind of like as a wireframe, then this face here between these two cubes is kind of within the shape now, isn't it? It's not on the surface anymore. So actually, this first cube on the left, there are only 5 of its faces that are external to the shape. Okay. Now, with the second cube that I just joined it onto, actually there are 2 faces that are internal, aren't there? Because also this top of this cube joins onto the bottom of the third cube. So actually there are only 4 external faces on this cube. Similarly, on the third cube, that shares 2 faces with other cubes, because like this one here, look, that is also shared between 2 cubes. So this face here is also kind of internal to the shape and not part of the surface anymore. So there are only 4 faces on that cube, and then on the last cube it's just got that one face that it shares with the cube next to it. So that one again, it's got 5 faces that are external to the shape. Okay, so then altogether you've got 5 plus 4 plus 4, so total number of faces of cube faces on surface, that's going to be the 5 plus 4 plus 4 plus 5 faces that are actually still on external to my new shape. That adds up to 18 faces. So then the total surface area is going to be those 18 faces times 9 centimeters squared of each of the faces. What's 18 times 9? 18 times 9, it comes to 162. So that's 162 centimeters squared. Question 11, here are some algebraic statements. From the list above, write down an example of each of the following. An expression. Now, expressions don't have equal signs in them, they're just collections of algebraic terms. So an expression would be a plus 2b. An inequality. An inequality has either a greater than or less than symbol in it. So there's only one of those. That is 2y is less than x. Now, an equation has an equal sign in it. Now, there are three of these that have an equal sign. That one, and that one. Now, it's actually the last one. It's 2x is equal to 5. That's the equation. Now, I'll tell you why it's the equation. Now, this one has only got one unknown in it, isn't it? Okay, that's what makes it an equation. This one has got 1, 2, 3, 4 unknowns in it. So this isn't an equation. We call this one a formula. So where you've got more than one unknown, you've got a formula that links them together like that. Okay, and now the other one, this one is actually what we call an identity. It's always true. It's kind of like a super equals, really. If you think about 3 lots of x plus 2, if you remove the bracket and multiplied it out, you would get 3x plus 6. So this is what we call an identity rather than an equation. Okay, so this one is an identity. This one is a formula. We already said this one is the expression. This one is the inequality. And this one is the equation. Okay, all right. So yeah, so you need to know each of those and be able to recognize them. Okay, talking of formulas, question 12 says rearrange this formula to make W the subject. So again, just as I was saying, you can see that you've got 3 unknowns in here rather than just 1. So it is a formula and not just an equation. If we want to make W the subject, we need to rearrange it so that I get W by itself. Now you can do this very much the same way as you do equations, by kind of adding, subtracting, multiplying, dividing things from both sides. Okay, so we want to try and isolate W, which means we want to try and get rid of everything else. Okay, now at the moment W is times by 2 and I've got 2h added to it. Now the order that you do this is like BIDMAS but backwards. So if you think about BIDMAS, Then I've got a multiplication in here and an addition. So multiplication comes before addition, normally in BidMaths. But when you're rearranging these, you kind of go through BidMaths backwards because you're kind of using inverse operations to work your way through. So that means I need to deal with the addition first. Now the opposite of adding 2h is subtracting it. So if I subtract 2h from both sides, it will cancel off this side. And what I'll get is p minus 2h is equal to 2w. Okay, and then now I've got 2w by itself, but I want w by itself. So I'm going to divide both sides by 2. That side is going to cancel with that one there. So I'm going to leave me with w on the right. And I'm just going to get p minus 2h over 2 on the left. Okay, that's all I'm going to do. That's kind of the answer. I'm just going to spin it around actually and write w at the front. So w is equal to p minus 2h over 2. That's my final rearranged answer. Question 13. Ellis has 28 meters of ribbon. They cut the ribbon into lengths of 60 centimeters. What is the least length of ribbon in centimeters that can be left over? Okay, well, first off, we've got mixed units here, haven't we? I've got meters here and I've got centimeters here. So I'm going to convert them both into centimeters. So 28 meters, that is equal to, well, 1 meter is 100 centimeters, isn't it? So multiplying through by 100, that is going to be equal to 2800 centimeters. So how many times does 60 go into 2,800? So 2,800 divided by 60. What's that then? How many times can 2,800 go into 60? That comes out to be 46.6 reoccurring. Okay, so that means that I could get 46 ribbons of length 60 centimeters out of this 28 meters ribbon, but I'd have a little bit left over, wouldn't I? Okay, because you can see it doesn't quite go in neatly, so there's going to be a remainder. So what I want to know is what that remainder is, rather than just as a straight division. So if I know it goes in 46 and a bit times, well, what is 46 times 60? What does the total ribbons that do go into it add up to? So 46 times 60, that comes to 2760. So I could make 46 ribbons of length 60, and that comes to 2760. So what is left over? So left over is going to be the difference between what I had to start with, 2800, minus the length of the 60 I can make. And you can see the difference between there is 40, isn't it? Okay, so he's going to have 40 centimeters remaining. This table shows the names and areas of 5 lakes. Well, not heard of many of these. Lagoda, Muero, Tana, Topozero, Victoria. Part A says write the area of Lake Mweru as an ordinary number. So here's Lake Mweru, and you can see that in standard form, you can see its area is 5.12 times 10 to the 3. Okay, so converting that into a normal number, you've got standard form power 3 here, which means I can either multiply it through by a 1 followed by 3 zeros, or I can just shift the decimal point 3 jumps to the right, can't I? So 1, 2, 3. So it's going to be 5, 1, 2, and an extra 0 then on the end. Okay, so that's 5,120. Part B says write the lakes in order of their area, starting with the smallest. Okay, well the one which is the smallest is going to be the one with the lowest power, isn't it? Because that is going to be the smallest magnitude. So this one here with the 2, that is going to be the smallest. So Topo 0 is the smallest. Okay, next power of 10 up is 3. So 10 to the 2 is hundreds, isn't it? And 10 to the 3 is in the thousands. So both of these lakes are have areas in the thousands. Now, obviously, 3,000 is less than 5,000. So Tana is going to be the next smallest, and then Mweru, because 3.2 is less than 5.12, isn't it? Mweru. Okay, and then I've got two lakes whose areas of the magnitude 10 to the 4, which is in tens of thousands of square kilometers, isn't it? So out of Lagoda and Victoria, you can see Lagoda's got 1.81 and Victoria's got 6.89. So Lagoda is the smaller of the two and Victoria is the largest. Ladoga next, and then Victoria. Okay. Part C says calculate the difference between the areas of Lake Ladoga and Lake Tana. Give your answer in standard form correct to two significant figures. Okay. So difference in mathematics means subtract, isn't it? So we need to take one away from the other. So we are going to be taking the smaller one away from the bigger one, aren't we? So which one's smaller? Ladoga and Tana. Tana is the smallest because it's 10 to the 3. And Ladoga is 10 to the 4. So I'm going to take the smaller one away from the bigger one. So that's going to be 1.81 times 10 to the 4 subtract 3.2 times 10 to the 3. Okay. Now, it's a bit hard to subtract numbers when you've got these powers, different powers on the end. But if I take a power of 10 out of 10 to the 4, so if I take 10 out of 10 to the 4 and leave it as 10 to the 3, and with that 10 I can multiply the mantissa part of the number and get 18.1 times 10 to the 3. So I've kind of taken a 10 out of the power and stuck it in with the mantissa at the front. Then I've got 18.1 times 10 to the 3 minus 3.2 times 10 to the 3. Now these two are now of the same magnitude, so I can go ahead and I can subtract the mantissa parts from each other. So 18.1 subtract 3.2. Well, 18 take away 3 is 15, and 15.1 take away 0.2 is going to be 14.9, isn't it? So that's equal to 14.9 times 10 to the 3. Okay. Now I'm going to take the 10 back out of the 14 and put it back in with the 10 to the 3. So that's going to be 1.49 times 10 to the 4. Final answer does ask for two significant figures though, so I'm going to round this off and say that is 1.5 times 10 to the 4 as the final answer. Asmi, Beth and Callum share a flat. Part A says the monthly rent is £760 and they share the rent in a ratio of 2 to 3 to 3. How much does Beth pay for rent each month? Okay, so presumably that's in order then. So A to B to C, Asmi to Beth to Callum is in a ratio of 2 to 3 to 3, isn't it? Okay. Now, basically here what we're doing here is dividing by a ratio, isn't it? Because we want to know what Beth pays. So if you add the parts together, 2 plus 3 plus 3, that means we have a total of 6 parts altogether, haven't we? 2 parts for Asmi, 3 parts for Beth, 3 parts for Callum, 8 altogether. Now dividing the £760 into those 8 parts, so 760 divided by 8, what's that then? Leave my calculator. 760 divided by 8, that comes out to be 95. So that means each share is worth 95. Okay, and then so to find what Beth has, we're going to take our ratio 2 to 3 to 3. We're going to scale it up by a factor of 95 then, aren't I? So Asmi's going to get 2 lots of 95. That's 190. Beth's going to get 3 lots of 95. Well, she'll have to pay 3 lots of 95. That's 285. And the same for Callum, 285. Now at this stage you might want to just double check your work by adding the 285 and the 285 and the 190 together. Just double check they come to 760. Mine do. So then Beth's then is that one in the middle, is 285. Okay, so how much does Beth pay? Beth pays 285 squids. Okay. Part B says Asmi, Beth and Callum also share the fuel bill in the ratio of 2 to 3 to 3. Callum pays £36 for fuel each month. How much does Asmi pay for fuel each month? Okay, so again we've got the ratio for Asmi, Beth, Callum, and they're in a ratio of 2 to 3 to 3. And we're saying that Callum gets paid, or pays £36 for the fuel. What do the other parts then have to pay? Well, Beth is the same as Callum, isn't it? So that's going to be 36 as well. What about Asmi? Well, if you have a look at what you have to multiply 3 by to get 36, 3 times 12 is 36, isn't it? So that's been scaled up by a factor of 12. So if I scale up this side as well by a factor of 12, then 2 times 12, that's 24. Okay. And so how much does Asmi pay for the fuel? That's that one there, isn't it, Asmi? So Asmi pays £24. Okay. Triangle A and triangle B are drawn on the coordinate grid. Part A says reflect triangle A in the line x is 0. Just take care here, x equals 0 is not the x-axis, is it? X equals 0 is actually the y-axis. It's this line here, that's our mirror line. Okay, so this point on the tip of the triangle of A is already on the mirror line, so it's 0 squares away, so it's going to stay invariant, isn't it? It's not going to move. The other 2 points are 1, 2, 3, 4, 5, 6, 7, 8 points away. 8 squares away, so they're going to be reflected, and they're going to be 8 squares on the other side of the mirror line. So they're going to be here at minus 8, 6, and at minus 8, 2. Okay, so once I've got my points, I reflect the points, not the lines. If you try and reflect the lines, you're going to mess up. So work out where the points go, and then join your lines, your points together with lines. Okay, it's the easiest way of doing it. Okay, I'm just going to label that A dash, the image of A. Okay, and then describe fully the single transformation that maps triangle A onto triangle B. So this is clearly an enlargement. Well, we call it enlargement in maths, but actually you can see it's shrunk. So it's a reduction really, isn't it? But we still call it an enlargement in the magical mathematical world. So yeah, it's enlargement with a fractional scale factor. So in order to describe this transformation fully, we need to know 2 things about it. We need to know the scale factor, what fraction it's been reduced by, and we also need to know the centre of enlargement. Okay. So first up, the scale factor. If you count the distance along this line here, look, that is 1, 2, 3, 4, 5, 6, 7, 8 squares, isn't it? That's 8 squares. Where it's matching one on the image is the equal one down here. That's only 2. Okay, so it's gone from 8 units to 2 units. In other words, it's a quarter of the size it used to be. You could do that with any other sides as well. So it would give you the same fraction. Okay, so if I'm going to describe this, I'm going to say it's an enlargement with scale factor of 1/4. And now I just need to find the centre of enlargement. So where is the centre of enlargement? Well, I can do that by using my ruler and drawing on some array lines. What I do is I find matching points on object and image, and I'm going to draw some lines through them. Okay, now these lines should converge on the centre of enlargement. I can already see where it is actually, but I'm just going to show you a little bit more. So another line going through here. And remember, I've got 2 points on the y-axis here, so the y-axis is a kind of array line as well. Okay, so you could have a ray line going that way as well. And anyway, you can see all of these lines converge on this point here, don't they? Which is 0, -6. So that is going to be the centre of enlargement, isn't it? So that's going to be at 0, -6. Okay. So note this is a 3-mark question, isn't it? And you get 3 marks, 1 for enlargement, 1 for the scale factor, 1 for the centre. Okay. So make sure you get all those 3 bits written down. Ling throws a 6-sided dice 300 times. The table shows the frequency of their results. Complete the table to show the relative frequencies. Okay, so we've got 1 done already. We already know that the relative frequency for 3 is 0.19. Now you're going to get the relative frequencies by, well, let's just give the formula. Relative frequency is equal to successful trials over total trials. Okay, so here total trials is 300, isn't it? So the total trials here is the number of throws altogether, and the successful trials, well, that's just, you know, the number of successes for that particular number. So for 3 there were 57 successes, and you'll see if you divide 57 by 300, the total number of trials, you're going to get 0.19. Yes, you do. Okay, so let's just do that with the others. We're just going to divide each one by 300. So 42 divided by 300, that is 0.14. Okay, 27 divided by 300, that is 0.109. 60 divided by 300, that is 0.2. 39 divided by 300 comes to 0.13, and 75 divided by 300, that comes to 0.25. Okay. Ling thinks the dice may be biased. Explain why evidence from the table could support their opinion. Okay. Well, clearly you've got quite a bit of variation here, haven't you? So if you have a look at the number 2, that has come up 0.09 times, and compare that to the 6 over here, which has come up 0.25 times, which is, that's almost 3 times as often, isn't it, actually, if you think about it. So 0.9 times 3 would be 0.27, so there or thereabouts. Okay, so that's going to be my evidence. So the relative frequency of 6 is 0.25 compared to rel freq of 2, which is 0.09. This is almost 3 times as much. Okay. Right. Then part 2 says, explain why the dice may in fact not be biased. Well, there isn't that many trials here, is it? 300, and sometimes you get a lucky run, don't you? So I'm going to say there is a small number of trials, and you should expect some variation. Question 18. A carpenter measures the length k meters of a piece of wood. They write 3.35 is less than or equal to k, which is less than or equal to 3.45. Put rings around all possible values of k in the list below. Okay, so which one of these lies in that range? Well, 3.349, that's too low. 3.39, yep, that's in the range. 3.44 is in. 3.45, well, that's right on the edge, but it doesn't count, does it? Because it has to be less than 3.45, and 3.55 is too big. Okay? So yeah, it's just those two. The carpenter says 3.35 is less than equal to k, which is less than equal to 3.45, means that the length of a piece of wood is 3.4 meters correct to the nearest centimeter. Explain how you know that she is incorrect. Well, I think if it was to the nearest centimeter, 3.4 meters is like 340 centimeters, and if we're saying it to the nearest centimeter, then that would give me a different range. That's going to give me anywhere between, well, if you think about a scale with 340 in the middle, then one below it to the nearest centimeter would be 339, and one above it would be 341. So the values that are around to 340 are going to be halfway or closer between those, isn't it? So the limit there is going to be 339.5, and this one is going to be 340.5. Okay, so then that's what my range would be if it was to the nearest centimetre. To the nearest centimetre, it would be so K would be between the lower limit of 339.5 and the upper limit of 340.5. Okay, I don't know what exactly how they want me to answer that, but that's an acceptable answer. I've shown what it actually is, which is different from what they're saying, so it must be incorrect. Right, complete the interval for 3.4 meters correct to the nearest centimeters. Oh, I've just did it. It's going to be 340.5. Question 19a. Amit says my normal typing speed is 40 words per minute. Therefore, I estimate that my normal typing speed is about 210 characters per minute. Each letter, space, and piece of punctuation counts as a character. How many letters per word is Amit most likely to have used in making the estimate? Show how you decide. First off, let's think how many times 40 words goes into 210. Okay, so how many times does 40 fit into 210? So 210 divided by 40, that comes out to be comes out to be 5.25. Okay, so if he's estimated that his typing speed is 210 characters per minute and he's doing 40 words per minute, then he's budgeting on 5.25 characters per word, isn't he? Okay, now remember, characters include spaces and pieces of punctuation. So I'm guessing what he's done then is he's saying that I've got a word. Each word is going to have a space or a full stop at the end, isn't it? So that's going to be one character. And then if that's 5 altogether, then I'm going to have a 4-letter word plus a space or a full stop, giving me 5. 5 lots of 40 is 200, and he's kind of allowed a few extra characters for other types of punctuation, like commas and things that are a little bit less frequent, I suppose. Okay, so I'm going to say that Amit probably used 4 letters for each word plus 1 space or full stop at end of each word, giving 40 times 4 plus 1 equals 200 characters. He has then added 10 more for other types of punctuation to give 210. Okay, so that's how I'm going to say it is. So Amit probably used 4 letters for each word plus 1 space or full stop at the end of each word. Given 40 times 4 plus 1 equals 200 characters, he has then added 10 more for other types of punctuation to give 210. Right, so then part B says Amit starts some homework at their normal typing speed. Amit types 52 words in 1 minute and 12 seconds. What may be true about the length of words that Amit has just typed? Show how you decide. Okay, well now is he going faster or slower than his usual amount when he's done this piece of homework? He's got 52 words in 1 minute and 12 seconds. So how many is that if I want to do it in 1 minute alone? So if I take 52 and I divide it by 1 minute 12 seconds, which is 72 seconds. That would be my words per second, and then if I times that by 60, that's going to give me words per minute again, isn't it? Okay, so 52 divided by 72 times by 60, that comes out to be about 43 1/3 equals 43.3 reoccurring words per minute. Now that is slightly more than his usual 40 words per minute. So he's typing faster, isn't he? So he's getting more words done in a minute than he normally does. Okay, so Amit is typing more words than usual. So the word length is likely to be less than 4 on average. Question 20. The diagram shows rectangle ABCD. DB is 13 centimeters and BC is 5 centimeters. Calculate the area of the rectangle. You must show your working. Okay, well, in order to work out the area of a rectangle, area equals length times width, isn't it, of a rectangle. Now we know the width is 5, isn't it? But the length, don't currently know that, do we? Okay, because we're not given that side of the rectangle. Okay, so we know this one is 5. We don't know L yet. Okay, now in order to work out what L is, we can use the fact that that CD is part of this right angle triangle here, isn't it? It's part of this triangle here. Okay, so this is a right angle triangle, and we know the hypotenuse of our right angle triangle. We know it's 13, and we know one side of the right angle triangle. So we can use Pythagoras theorem, can't we, to find the other side? So using Pythagoras theorem, then we know that c squared is equal to a squared plus b squared normally. That's when we're finding the long side, but we know the longer side here. So spinning that around, we know that b squared equals c squared minus a squared. Okay, that's the one we're going to be using for the shorter side. Okay, so then subbing in what I know. So I know that c squared, well, c is going to be this 13. It's the longer side squared, isn't it? So that's going to be 13 squared. And a is the width that we know. That's going to be 5. So 13 squared minus 5 squared. 13 squared, that's 169. 5 squared is 25. Take one away from the other, that is 144. And we want b though, don't we? Not b squared. So we need to square root that. Square root of b squared, that is 12, isn't it? B is 12. Okay, so once I know that b is 12, then I know that that's going to be my length, then, isn't it? That's what goes here on this side of the rectangle. So I know then that my length is 12, my width is 5, and that gives me an area of 60 centimeters squared. Question 21a. A straight line is equation y equals 2x minus 1. Write down the gradient of the line. Well, the equation for any straight line should be in the form y equals mx plus c. So we can see here that our m value is that coefficient in front of the x, and the c value here is that minus 1 on the end, isn't it? So what is the gradient of this line? M is equal to 2. Here are the equations of 4 straight lines. I've got y equals 2x plus 3, y equals 1 minus x, I've got y equals half x plus 4, and y equals x minus 1. Which of the 4 straight lines is parallel to y is equal to 2x minus 1? So if the two lines are parallel, it means they must have the same gradient. So we need to read the gradient out of these. So here, this first one has a gradient of 2. So that one would be parallel. So this one, m is 2. This one, the gradient is, well, you can't really see a number in front of x, but I've got a minus sign. That means that m is minus 1. It's minus 1, not of x, or minus x. So x is minus 1 for that one. Here m is a half, and here m is 1. So there's only one that has got a gradient of 2 that matches my other one. It's that one there. So it's the line y is equal to 2x plus 3. Okay. Finally, part 2 says, a student says y equals a half x plus 4 is the steepest of the 4 straight lines because it has the largest number added. Explain why the student is wrong. Well, the student is wrong because he's looking at this 4 here and saying that's the largest number added, so it must be the steepest. But that number on the end, that is the y-intercept, isn't it? It's not the steepness. It's the gradient here, the number at the front, that represents steepness. So he's wrong because 4 is the y-intercept, not gradient. The steepest line would be y equals 2x plus 3 because it has the largest gradient. Okay. Part C says, here is part of the graph y equals 2x minus 1. The line continues to the right. Will the line pass above, below, or through the point 45, 90? Shall you decide? Okay. Well, what I'm going to do is I'm going to sub the x-coordinate into the equation and find what the corresponding y-coordinate should be. So when x is, the x-coordinate is this one, isn't it? So when x is 45, I'm going to sub that into the equation and I'm going to see what value of y I get. Y is equal to 2 lots of 45 minus 1. So I've just replaced the value of with x with the value of x. So 2 times 45 is 90. Take away 1, that's 89. Okay. So actually, line is going to pass through 45, 89. So 45, 90, that's going to be 1 square above, isn't it? So 45, 90 is above the line. Okay, because its y coordinate is 1 more, so it's going to be 1 unit higher than the line. Okay. Question 2. In this question, all measurements are in centimeters. Now we've got 2 shapes here. One is a square. It's got sides x and x. And the other one is a rectangle. It's got sides 4 and 2x plus 5. Now it says the square and the rectangle have the same area. Show that x squared minus 8x minus 20 is equal to 0. Okay. So I think what we need to do here is to work out algebraically what each of the areas is, and then because we know that they have the same area, we can equate them, or we can put an equal sign between them, and then we can rearrange, and hopefully it gives us that what we've been given. Okay, so let's start off with the area of the square. That is going to be length times width, which is x times x. That is going to give me x squared. And the area of the rectangle, that's going to be again length times width, but this time that is 4 times 2x plus 5. I'm going to put that in brackets. Okay. In fact, I'm just going to probably write it as 4 lots of 2x plus 5. That's probably a neater way of doing it. Okay. Now you have to put brackets in because when I multiply 2x plus 5, I need to multiply the 2x and the 5 by 4. Okay, that gets multiplied by 4, and so does that. Otherwise, you're going to get the wrong answer. So that is 8x plus 20 altogether, removing the brackets. Okay, so then if we're saying that these areas are the same, so if area of the square is equal to the area of the rectangle, then what we're saying is that x squared is equal to 8x plus 20. Okay, and then all I'm going to do is I'm going to subtract 8x and subtract 20 from both sides, and that's going to give me x squared minus 8x minus 20 is equal to 0 as requested. Okay, and then in the second part we need to go on and solve it for x. Okay, so we've got a quadratic equation equal to 0. If you want to solve it, then probably the easiest way to do it is to factorize it like that. Okay, so I've got x squared at the front, so I'm going to have x here and x here. Now at the back I've got minus 20, haven't I? So what are the factor pairs of 20, that two numbers that multiply together to give me 20? Well, there's 1 and 20, 2 and 10, 4 and 5. Now one of those pairs, if one is positive and one is negative, needs to add up to negative 8. Okay, I think it's going to be that one there, the 2 and the 10, because they have a difference of 8, don't they? So if I make the 2 positive and the 10 negative, that's going to deliver me the minus 8 in the middle. Okay, so then that's going to be x plus 2, x minus 10. Okay, so if I've got two things then multiplied together that give me 0, then one of the things must be 0, or the other thing must be equal to 0. Okay, it's just a necessity, isn't it? Two things multiplied together, one of the things has to be 0. Now if x plus 2 is equal to 0, that means x is minus 2, and if x minus 10 is equal to 0, that means x is 10. So I've got two solutions, x is minus 2 and x is 10. Part C says, explain one of your answers in part B is not possible in the context of the question. Now remember, we got the solutions, x is minus 2 and x is equal to 10. Now one of those solutions is definitely not possible because I can't have a side of a square that is of length minus 2. Okay, I can't have a negative length of a square. That doesn't make sense in terms of this question. So minus 2 is a solution to the equation, but it's not a solution to the actual problem because it doesn't work. Okay, so that one is the one that isn't going to work. Okay, so I'm going to say x equals minus 2 is impossible as the length of the side of the square cannot be negative. Okay, makes no sense. Okay, so that means it must be x is 10 is the solution. Okay, so if I want to write down the following, the area of the square then, so then the area of the square is going to be 10 times 10 then, isn't it? X times x, which is 10 times 10, that's going to be 100 centimeters. And the length of the rectangle, the area of the the length of the rectangle, the length of the rectangle is 2x plus 5, isn't it? So that's two lots of 10 plus 5. 20 plus 5, that's 25, isn't it? Okay, so that gives me 25. The bag of sweets contains jellies, mints and toffees. The ratio of jellies to mints is n to 2. The ratio of mints to toffees is 5 to 3n. Work out the ratio of jellies to toffees. Give your answer in its simplest form. Okay, so we've got two ratios here. They're partially algebraic. So I think the first step is to try and kind of bring the two things together and kind of form them into one ratio. Okay, so we've got jellies and we've got mints and we've got toffees. Okay, we know that the ratio of jellies to mints is n to 2, and we know that the ratio of mints to toffees is 5 to 3n. Okay, now I think what we want to do is try and combine those together. Okay, now the way to do that is to find like a common denominator, or a common multiple of these two numbers here, 2 and 5 in the middle. So if we can kind of scale these up so they're both like some same multiple of these, then we can kind of make one ratio. Okay, so the common multiple of 2 and 5, that's going to be 10, isn't it? So if we can make this ratio into 10, then we can bring down the other parts and and kind of form one ratio then. So let's take this first ratio n to 2. Now to scale that up so that the mince is 10, I would need to multiply through by 5, wouldn't I? So doing that to the n as well, I'd get 5n to 10 is the equivalent ratio, isn't it? Okay, and then on the other side, 5 to 3n. If I want to make it 10, I'm going to have to double it up, aren't I? I'm going to times that by 2. So 5 times 2 is 10. I've already got that written down. But 3n times 2, that's going to give me 6n. So I've got 5n to 10 to 6n. And then it says work out the value, the ratio of jellies to toffees. So we want to compare this one then, the jellies, with this one, the toffees. Okay, so this is in a ratio. So jellies to toffees, that's going to be in the ratio now of 5n to 6n, isn't it? Okay, and then all I need to do now is divide both ratios by n. Okay, so then we can see that then these are going to be in the ratio of 5 to 6. Okay, so 5 to 6 is my final answer. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.